coded data. And we'll look at an example, say like, if we have the data set 101, 105, 103, 107, 109, if we had to manually do this, it'd be quite difficult to just be adding up all those hundreds. So what if we just, and we can notice something, that they're all quite similar actually. If we subtract 100 from all, we've got 1, 5, 3, 7 and 9. And so this would be much easier to find the mean from, because, well, 1 plus 5 plus 3 plus 7 plus 9 equals 25. 1 over 5 equals 5. So we'd get a mean of 5. But that's not at all close to 101, 105, 103, 107, 109. So what can we do? Think about this. We know our mean formula is going to be sum of x over n. But what we've done is we've actually taken away 100 from all of them. And so if we take 100 away from all of them, we're taking away 100 n times, aren't we? So then we're doing a coded mean of sum of x over n, and we're actually taking away 100 from all of them, which means we're actually taking away 100n, or dividing that by n, and then if we split up the sigma, we get negative 100 n over n, so you get 100. So what we do is, we notice that we've got the real mean here, and our coded mean, if we say it's the x minus over n. So the relationship is, so the n equals x minus 100 over n plus 100. So we just calculate our coded mean, then just add 100 back, and we can generalize this as sum of x minus b all divided by n plus b equals your sum of x over n. Do an example of lengths of 500 bolts in millimeters have sum of x minus 40 equals 875. Find mean length. So what we do is we have x minus 40 over n, and we need to add 40. So we take 875, divide by 500, and add 40. That will give us 40.35 millimeters. And once again, this could take a bit of rearrangement. It might have given you two different coded values, and you might have to do a bit of a simultaneous equation. It might have given you the true mean, and it might have asked you to find the sum of x minus 40, and it might have given you n, and you have to figure that out. But once again, it's just algebra and it's just practice. But the key point here is, if you take away or add a value to every single one, and you take that average, you just need to add in whatever you subtracted in again. And this isn't tested, but just so you know, if you did ax plus b over n, this is just to get sum of x over n. What you'd do is you'd subtract the b, like we did before, and then you'd divide it by a. Anyway, we'll just do kind of another example, students investigated drink prices in 24 shops in a town and 16 in a village. If this is T and this is V, it's given that T minus 1.1 equals 1.44 and V minus 1.2 equals 0.56. So it's going to ask you to find mean price combined. Yeah, this is price, by the way. So what you'd have to do is minus 1.1, and also you'd add 1.1 times n to get your sum of t again. So you get 1.44 plus 1.1 times 24, and on this side you're going to get 1.2. It's going to equal, you're going to have to add 1.2 times 16. It's going to be 0.56 plus 1.2 times 16. So it's going to give us 7.84 over here and 75.2 over here. And so we add those together and divide it by 40, because that's 24 plus 16. It's going to give us 2.576. So that is 2.58, because we round to the nearest cent.